So we're going to take a look at 10.5, surface area of pyramids and cones, the first day of it. Our math humor, what's refreshing and it has triangular lateral faces?
A pyramid.
Oh. Now when we take a look at pyramids, there are several different parts for each pyramid that we want to take a look at. First off, the vertex. The vertex of your pyramid is this top point and is the opposite of my base on my pyramid. From each vertex, there's something called a slant height, and a slant height goes from the vertex to the midpoint of each edge on the base. That is in blue here, and we normally denote the slant height with a cursive L. We're going to need that when we find the lateral area and surface area of these pyramids. It'll play a role in our formulas. Also, to pay attention to, you should realize that with each regular pyramid, every lateral face that we have is going to be an isosceles triangle, so it's got two congruent legs. And the last thing is the altitude on my pyramid is the segment that goes from the vertex to the center of my base. So those are just a couple parts that are going to help us out when we're finding lateral and surface area of pyramids. Now we're going to take a look at lateral area and surface area and the formulas for the pyramids. When you're talking about lateral area or adding up all of the areas for the lateral faces of a pyramid, you're going to use the formula 1/2 PL. P represents the perimeter of your base, and L here represents the slant height, what I talked about before. If you're taking a look at the lateral area, and I want to jump from lateral area to surface area, that would be the area including not only just the lateral faces, but also the one base. Hence why surface area of a regular pyramid is still going to be 1/2 PL, so 1/2 the perimeter of the base times the slant height of my pyramid. But then we're also going to add on the area of my base, because there's only one base in each pyramid. Now that we know what the lateral and surface area formulas are for regular pyramids, we're going to go ahead and put those to good use. So the pyramid I'm giving to you here has a hexagon as a base because it has 6 sides. And we're going to start off by finding the lateral area first. So lateral area, according to my formula, is 1/2 my perimeter times my slant height. And I use a cursive L. So I've got 1/2. Talking about perimeter, since I've got 6 sides, in each side of the base, each base edge is 10, our perimeter is going to be 60 inches. Then the slant height, if I take a look, I notice from the vertex to the midpoint of the base edge, that's 16 units. So that's going to be my slant height. So if I take 1/2 of 60 times 16, I'll end up getting 480, and we're talking about lateral area, so it's inches squared. Now that I have my lateral area, my surface area said it's going to be 1/2 my perimeter times my slant height plus the area of the base. Well, we already figured out from here that 1/2 perimeter times slant height was 480. So I'm going to go ahead and put that in. Plus, it's this plus capital B that I'm going to do off to the side here. And we're going to figure out what the area of the base is. Now, from the previous chapters, you know how to figure out the area of a hexagon by using 1/2 apothem times perimeter. That's where we're going to get stuck a little bit, I think, is if you can't remember the area formula for a polygon, a regular polygon. You got to remember it, though. So here's my hexagon that I've drawn out, and I'm kind of narrowing things down here. I know that on my hexagon, the base edge is 10 units. So if my base edge is 10 units, we know that this little guy right there, half of my base is going to be 5 units. And then to figure out, always in a hexagon, what the apothem is, you take whatever half of the base was, so 5, and you multiply by a square root of 3, because it's a 30, 60, 90 degree triangle. So the apothem that I'm working with is 5 square roots of 3. That's what we're going to put in to my formula for the area of the base. So 1/2, 5 square roots of 3 times the perimeter. We already talked about the perimeter being 60. So when I do the multiplication through with that, 1/2 of 60 is 30 times 5. It gives me 150. So I have 150 square roots of 3. That's what I'm going to end up putting in for the area of my base. So I have 150 square roots of 3. Now we're going to put inches squared. You can either leave it like this because there's no way in which you could put 480 and 150 square roots of 3 together because they're not like in their respects. This does not have a radical. That does. So I can't put them together. Otherwise, if you throw it in your calculator, you could come up with 739.8 inches squared. So So since we're talking about pyramids, we might as well throw some cones out there because a cone is really, really similar to a pyramid. The only difference is its base isn't a polygon, it's actually just a circle. So the vertex that we're working with is at the same exact spot. It's at the top point here, and it is directly above the base of my cone. And the segment that attaches the vertex to the center of our circle is called an axis. It was the altitude on the other one. This is called an axis on my cone. A right cone is a cone that has an axis that is an altitude, so it forms a right angle. An oblique cone, which we never really deal with, is where my axis is not an altitude, so it's not forming a right angle with my base. The other thing, too, is the slant height's still the same. It's still from the vertex down to the base itself. And we're going to use the slant height yet again in our formulas when we're talking about finding the area or lateral area and surface area of our cones. So just reiterating what we talked about, we said in a cone, the slant height is the distance from the vertex to the base along the surface of the cone. That's my slant height. The lateral area is just going to be the area around the cone, not including the base. And then when we talk about surface area, the surface area is going to include the area of the base also. So the surface of the cone, excluding the base, is called my lateral surface. But if I add in the area of the base, that's my surface area. Now, how do I figure out lateral area and surface area of a cone? Well, we're going to follow these formulas. If I take a look at the lateral area of a cone, all you have to do is take pi times the radius of that base times the slant height of that base, and that'll give you the lateral area around it. If you wanted to get the surface area, you would still have whatever your lateral area was, and then you would just add on the area of the base. And we know the area of a circle is pi r squared, so surface area is pi rl plus pi r squared. Since cones are pretty much straightforward, what we're going to do here is I'm going to have you find the lateral area, and I'm going to remind you that it was pi rl, and then I'm going to have you find the surface area, and that was pi rl plus pi r squared. I'm going to have you do that on your own. You're going to pause the video here, and then when you're all set and ready, you're going to start it up again, and we'll go ahead and check our answers together. So let's go ahead and take a look and see. If I'm finding my lateral area, I needed pi, r, and l. So I knew my radius of this cone was 8 inches. Slant height. I currently don't have the slant height. So hopefully you saw that you can use the right triangle here. And you knew this was 8 and the height was 15. So I could use Pythagorean theorem, 8 squared plus 15 squared equals L squared. And I could solve for my L and get a 17. Otherwise, if you knew your Pythagorean triples, 8, 15, 17, 17 would be the hypotenuse. Once you tell me what the slant height is, you can plug that in. So 8 times 17 times pi gives me 136 pi inches squared. For the surface area, pi RL, we just figured that out to be 136 pi plus the area of the circle of the base. So pi r squared, it would be r for 8. My radius is my 8. So 64 pi added on to 136 pi gives me 200 pi inches squared. So all you have to do is make sure you know these formulas, make sure you understand how to find slant height, and don't forget how to figure out what the area of a regular polygon is, because that's really going to help you out with these. Make sure if you have any questions also, ask your teacher. We're more than happy to answer those for you. Until next time, have a great night.